The mean ATM withdrawal is $67. Assume that the standard deviation for the withdrawals is $35. Do you think the variable ATM withdrawal is normally distributed? If not, what shape would you expect to have? Well, with this one, think about it. People go to the ATM to get money out. And usually, if you get money out, you're going to get a significant amount out, not just $5 or $10 at a time. So I would say that this probably would be no. And if I had to think of a distribution, I would think about it like this. It'd probably go up and then down drastically. So I would think that this is probably more skewed right. So with the skewed right distribution, now, if a random variable of 50 ATM withdrawals is obtained, describe the sampling distribution of the mean X-bar withdrawal amount. So the actual withdrawal amount now, if it's a sampling mean of 15, is going to be normal. As the sample size increases, it gets closer and closer to a normal distribution. But we do have to calculate out the new mean and standard deviation. So the mean of the sample means is going to be equivalent to the population mean, which is $67. And the standard deviation of the sample means is going to be the population standard deviation divided by the square root of n, or in this case, it'll be the $35 divided by square root of 50. So on our calculator, it'll be 35 divided by square root of 50. And I get 4.9497. Write the whole decimal down. Now we're going to determine the probability of obtaining a sample mean withdrawal amount between $70 and $75. So it's going to now be between $70 and $75. So let's go ahead and change that sample mean. And the sample mean is going to be in the middle, and it's going to be between $70 and $75. So setting up our probability statement. Also on our curve, if you remember, we're going to have $67 as the mean, and our new standard deviation of 4.94 is going to be on either side. Let's use StatCrunch to calculate the probability. In StatCrunch, we're going to have to change the mean to our new mean, which is $67. And our standard deviation we're going to change to be 4.94, that whole standard deviation there. And also it's going to be between, so I'm going to make sure I hit the between button. And it's going to be between $70 and $75. Hit compute. And there we go. It calculates that for us. Also, if we hit the 68, 95, 97 tick marks, remember it does the standard deviations as well. Filling in our curve here, it's 67, then 71.9, 76.8, and then on the other side 62.1 and 57.2. And it's between 70. The mean's between $70 and $75. So we'll go ahead and label that here. So our answer, our probability answer, is going to be 0. And if I round to 2 or 4 decimal places, 2192. So that's going to be the area right there. Make sure I label that area in between here, 0.2192. And so our sentence would read like this. If 50 withdrawals are taken, the probability, the mean amount, is between 70 and $75, is approximately 0.2192 or 21.92%. So that sounds about right. Usually people withdraw in terms of 5s or 10s or something like that. They would normally withdraw like $72 or something like that. So that would be about right.